Good morning. My name is Bryan Owens. Today I will be speaking about deploying infrastructure through AWS Cloud Development Kit. I don't know if you all are familiar with a topic in DevOps referred to as infrastructure as code. It is defined in Wikipedia as managing and provisioning computer data centers through machine-readable definition files rather than through physical hardware configuration or interactive configuration tools. Now, this is the most common and relatively universal definition for this. For it, a number of tools have emerged. In Amazon Cloud Infrastructure, we have two of the largest ones. First would be Amazon CloudFormation. This is one of the earliest tools for managing infrastructure as code. It was released in 2010. It is Amazon's principal tool for managing their infrastructure. It covers a number of resources. In fact, just about everything that they put out, the 500 plus resource types that exist, they will usually update CloudFormation almost immediately with any new ones. Over the years, it has grown to incorporate a number of their own internal services, such as Parameter Store, which can be used to store Amazon CloudFormation's own types of variables and other sorts of data, as well as KMS. And they even include a visualizing GUI for those who are not developers or engineer types who want to be able to kind of just build one through a visual interface. It is principally written in JSON, though it was years later, a great request. They added YAML, so you can basically write these templates in two different styles. And when you upload CloudFormation templates, they are stored as stacks. Now, moving on to the other, probably one of the other most popular tools for this would be Terraform. Terraform is HashiCorp's primary tool for managing infrastructure. It was released in 2014. It followed on Vagrant and Packer, which are two tools which are commonly used in DevOps. Terraform and Packer work closely together. It has its own suite of tools which can be included, such as vaults for secret management. And they have created their own uniform configuration language called HCL. Theirs gives you a slightly larger range for state management. It is normal for testing to create TF state files for individual DevOps developers. The more common for production is to either store it in S3 buckets, or now you can store these things in Dynamo. Terraform clips very closely to CloudFormation. They do not have quite the extensive support for it that CloudFormation does, but they usually stay hot on their heels. Any sort of tool being released for this would, they will update rapidly afterward. Now, there is a certain element to these tools that a lot of people don't think about, which is, and as you can see here, this is how the code for both looks. These are, this is Terraform here. And as you will see, this is a Terraform script creating code commit repository and a pipeline. And here you see a code commit repository and pipeline being created in CloudFormation. Now, to anyone who's a developer, there's a certain thought that comes to mind, which is, this is not really infrastructure as code. More like infrastructure as templates, which has been a common element in DevOps development. We like having our templates, which makes it pretty easy to follow and very simple for interpreters to build from. However, there is, in the last couple of years, been a third option, which Amazon has given to us. It gets around three of these limitations, which are common. One is both CloudFormation and Terraform have problems creating things such as conditional blocks. So if you wanted to have a if-then, CloudFormation, you can put if-thens in, though they are somewhat difficult. Going through a list of items, also possible, but somewhat, you have to really dive into the deeper logic of how CloudFormation or Terraform works. One other problem is been, especially if you work with CloudFormation, handling testing and error catching. Usually don't catch your error until the template is almost completely through. Introducing a third option, Cloud Development Kit. Amazon, pulling from a lot of the requests for both CloudFormation and Terraform, they have created a library framework that addresses a lot of these requests, and they have created a library that actually exists in multiple languages. So for developers, if you're familiar with Java or C# or JavaScript, including Go now has been included. This gives developers and DevOps engineers who are partial towards writing, code for their infrastructure, the ability to create truly code-based and extensive libraries for managing infrastructure. Now, unlike some code libraries, the code that is the output of CDK will be translated into CloudFormation templates. And because of that, it does give the same level of support that CloudFormation will offer. However, this does also give developers access to Amazon's native APIs, which gives the programmability for options that are lacking in both CloudFormation and Terraform. Where is CDK a good fit? If a dev team would like to, build on a infrastructure, if it's a greenfield, neither Terraform nor CloudFormation have already been chosen. This gives a dev team that already has a strong understanding of, say, TypeScript or Python, the ability to just jump right in and start developing their own infrastructure requirements. This also creates the ability to solve problems that could normally be addressed through AWS APIs. Say if you were working in an environment that already has an extensive development, but does not yet have its own infrastructure management. So let's get on to the demo. Now, when one is executing a pipeline stack, it is really simple. I'm inside my pipeline demo. I'm going to call the command CDK deploy. And as we'll see here, this will generate a list of all the resources that it is about to create. And of course, the final, do I wish to deploy this? And I do. And as we see here, it is starting by generating a base stack. We have 19 resources it will start creating. Now, while we're waiting for this to execute, let me give you a little tour of the code. A standard project for a CDK application will have a library section, the direct binary executable. You, of course, can build on these. As your infrastructure develops, you could have specific sub-libraries for addressing IAM policies, autoscalers, and eventually you can incorporate the AWS APIs to make direct queries to other CDK deployments. As CDK inside of Amazon is treated as its own unique resource, you can query previously deployed CDK libraries. Now, in this example, I have used TypeScript. So here we will look at the base binary, what it will do is it will instantiate the demo pipeline stack. And calling from that library, as we see here, this is my simple class, which will first, it will create a repository. It will then upload the code that I've already submitted to my S3 bucket. Once this resource is created, it will copy this code over into the Git repository. It will then build my pipeline, creating a stage for the code commit that was just created. And it will then create a build stage. In this case, it is a simple Node.js application. And one extra here that can be expanded upon is tagging. In CDK, tagging becomes a very simple effort. You simply add the tags you wish. If, say, later on you choose to update these or add new tags or update or remove tags, this will cascade through all resources for which tagging can be applied. Now, as I said earlier, CDK actually supports multiple languages. If you wish to do this in Python or Golang or Java, these are all available. They use the exact same library specs. They're in their documentation. Each of these functions are mapped out to each language. And similarly, they support their APIs are supported in these languages as well. As we see here, we're already in progress. Now you can see here, I'll pull up CloudFormation. You can see as CDK is executing this, we can see the actual output here from CloudFormation. We're almost done. Now, when you update these libraries, ideally you will be executing these. If this is to be deployed to a production environment, you'll be doing this through its own pipeline. CDK is perfectly capable of running inside of a code build instance, just as long as you make sure that that instance has the correct permissions to execute as a CloudFormation user. Let's see if our code commit is finished yet. There we go. There's our demo repository, and we have uploaded our app. And we are now complete. Let's see the rest of it. We now have our pipeline. And our pipeline, by default, a pipeline that is created through this process will be set to trigger its build based off of a commit to the branch. So it has already detected the source code that has been pushed in, and it has already triggered our code build. As we see here, we have our tags. All right. So that is a deployment through CDK. Do we have any questions?
Hey, Brian, thank you. Yes, we do have one question in the chat.
Okay.
So it says, is the sample code available in GitHub to have as reference?
I can make the sample code available, yes. I did not have a repository for Cognizant available at that time, but I can definitely make that code available.
Great, thanks. That's the only question we have for now. Maybe we can wait 1 minute.
Sure. And for anyone here, I can definitely also make sure the spreadsheet is available. These are some excellent resources for CDK. Of course, you have Amazon's direct documentation. Their examples library is very helpful. In fact, that was I looked through parts of GitHub to put this particular presentation together. Now, a common reference is for parts that are made for CDK is called constructs. And so they have a library of pre-created constructs for various applications put together already. And on GitHub, there are awesome lists, which is a very extensive list of resources for various topics. And this is the awesome list for CDK. Thank you, everyone.